Picture this, you're standing in a cave in southern France. It's 40,000 years ago. Outside, the wind howls across glaciers that stretch to the horizon. Inside, a fire crackles, casting shadows on ancient walls. And sitting across from you is someone who looks almost human. Almost. Their brow ridge is heavier, their nose is broader, their body is built like a tank. They're staring at you and you're staring back. And in that moment, both of you are wondering the same thing. Friend or enemy? And here's what makes this absolutely insane. That moment happened. Not once, not twice. Thousands of times across Europe and Asia. Two completely different species of human, face to face, making decisions that would echo through 40,000 years of history. And if you're watching this right now, if your ancestors came from anywhere outside sub-Saharan Africa, you're living proof that at least some of those encounters ended with something more than just talking. You've got their DNA inside you. Between 1 and 4% of your genome came from them, from the Neanderthals. So if you're here to relax, to wind down, to maybe drift off to sleep while learning something fascinating, you're in the right place. Hit like if this helps you chill out, and drop a comment with where you're watching from and what time it is. Last video had people from Tokyo, Toronto and Tasmania all tuning in. The internet's wild. Let's dive into one of the most mysterious, complicated and honestly kind of tragic stories in all of human history. The story of what really went down when we met our closest relatives. And trust me, it's way more complex than you learned in school. About 600,000 years ago, something happened that would change everything. The human lineage split. One group stayed in Africa. They'd eventually become us, Homo sapiens. The other group left, heading north into Europe and east into Asia, and over hundreds of thousands of years as ice ages came and went, as the climate swung wildly between frozen tundra and temperate forests. That second group changed. They adapted. Their bodies transformed to handle brutal cold. Their brains grew enormous. They became the Neanderthals. Now forget everything you think you know about what Neanderthals looked like. Seriously, wipe the slate clean. That image of the hunched over, stupid caveman dragging a club, complete garbage. That whole misconception came from a single skeleton discovered in 1908. One old man who had severe arthritis. His spine was bent from disease, and scientists back then assumed that's how all Neanderthals walked. They were dead wrong. Real Neanderthals were built like absolute units. Think professional wrestlers or heavyweight MMA fighters. The average male stood around 5'5" and weighed about 185 pounds, but that weight was almost pure muscle. When archaeologists study Neanderthal bones, they find muscle attachment points that would make modern bodybuilders weep with envy. The strongest Neanderthals could probably deadlift over 1,000 pounds. Their arm bones were so thick, so incredibly dense, you could probably use them as clubs themselves. But here's where it gets really interesting. Their brains were bigger than ours. Not just proportionally bigger, actually literally bigger. The average Neanderthal brain measured about 1,600 cubic centimeters. Modern humans? We average around 1,350. The largest Neanderthal brain ever found belonged to a guy scientists call Ahmad. His brain measured 1,736 cubic centimeters. That's one of the biggest human brains ever recorded in the fossil record. So, does that mean they were smarter than us? Not exactly, because brain size isn't everything. It's about organization, about how the brain is structured, about which parts do what. Neanderthal brains were shaped totally differently from ours. They had massive visual processing areas at the back of their skulls, and that makes perfect sense when you think about it. These people lived at high latitudes where winters were dark and brutal. They needed to see in dim light, to track prey at dawn, to hunt at dusk when shadows played tricks on your eyes. But all that brain space dedicated to vision meant less room for other stuff. The frontal regions, where modern humans do complex social thinking, where we plan abstractly, where we imagine distant futures and hypothetical scenarios, those areas were smaller in Neanderthals. They were absolutely smart, no question, but their intelligence worked differently than ours. It was specialized for different problems. Their bodies were engineering marvels for their environment. Short limbs to conserve heat, barrel chests with massive rib cages housing enormous lungs. They could gulp down huge amounts of oxygen to fuel their powerful muscles, and those muscles were different from ours at a cellular level. More fast twitch fibers built for explosive strength and power rather than endurance. They were sprinters and wrestlers, not marathon runners. That huge nose of theirs wasn't just for show, it was an adaptation to warm, freezing air before it hit their lungs. When you're surviving Ice Age winters in Europe, every tiny advantage matters, and their faces were distinctive. Massive brow ridges over deep-set eyes, a mid-face that projected forward, making their whole face look pulled outward, no chin to speak of, a bump at the back of the skull called an occipital bun, where powerful neck muscles attached to support that heavy head. They looked different from modern humans, sure, but not alien, more like a cousin you'd recognize at a family reunion, someone who shares your features but in a slightly different configuration. These people weren't just surviving, they were thriving. For over 300,000 years, they dominated some of the harshest environments on Earth. They lived through multiple ice ages. They hunted woolly mammoths, woolly rhinoceroses, cave bears, animals that could absolutely destroy you if you made one wrong move. And they were incredibly smart about how they did it. Neanderthals invented sophisticated stone tool technology called the Mysterian industry. At its heart was something called the Levallois technique. Picture this. You take a stone core and carefully shape it from multiple angles, like you're sculpting it. You prepare it meticulously, then with one precise calculated strike, you knock off a perfect flake that's already shaped exactly the way you need it. No trial and error, no random bashing. That requires serious planning. You need to visualize the final product before you even start. That's abstract thinking right there. They made specialized tools for specific jobs, scrapers for preparing animal hides, points for spear tips, knives for butchering meat, awls for punching holes in leather. They had toolkits with up to 40 different types of implements, each one designed for a specific purpose. That's not instinct, that's culture, that's teaching and learning and passing knowledge down through generations. And here's something that should make you respect them even more. They took care of each other. Archaeologists have found Neanderthal skeletons showing severe injuries that healed over time. One individual from Shanidar Cave in Iraq had been smashed in the head when he was young. The injury blinded his left eye and completely paralyzed the right side of his body. His right arm withered away from lack of use, but he lived to be about 40 years old. In Ice Age Europe, That's ancient. Someone had to feed him, protect him, carry him when the group moved. That's not animal behavior. That's compassion. That's recognizing the value of an individual beyond their immediate utility. They buried their dead too. No other species before them ever did that. At La Ferracie in France, archaeologists found a rock shelter where multiple Neanderthals had been carefully laid to rest. Some graves had stone tools placed with the body. Others had animal bones arranged in specific patterns. And at Shanidar Cave, one burial had pollen from flowers scattered around it, suggesting they might have placed flowers on the grave. We can't know if they believed in an afterlife. We can't read their minds. But they clearly felt something profound for their dead. They marked the moment. They ritualized it. They made death mean something beyond just the end of life. Neanderthals might have even made art, or at least they probably did. In caves in Spain, archaeologists found red hand stencils and geometric designs painted on walls over 65,000 years ago. That's before modern humans even arrived in Europe. If Neanderthals made these paintings, and the dating strongly suggests they did, then they were doing symbolic thought, abstract representation, creativity, all on their own, without any influence from modern humans. So these weren't dumb brutes stumbling around in the dark. These were people. Different from us, absolutely, but people nonetheless. They had culture, they had feelings, they had thoughts, they had lives that mattered to them. And then, around 60,000 years ago, everything changed. Modern humans, Homo sapiens, started leaving Africa, not in a trickle, in waves, thousands upon thousands of people pushing north into the Middle East, then spreading east into Asia and west into Europe, into Neanderthal territory. For over 100,000 years, the two species had occasionally bumped into each other in places like the Levant, that region around modern-day Israel and Lebanon. There's genetic evidence of brief encounters dating back 120,000 years, but those were just that, brief encounters, temporary overlaps, small-scale interactions. This was different. This was a full-scale migration, an invasion, if you want to call it that. Now imagine you're a Neanderthal living in Europe. Your people have been here for hundreds of thousands of years. You know every valley, every cave, every seasonal migration route of the herds you depend on. This land is yours. It's been yours forever. And then strangers show up. They look weird, taller, more slender, with flat faces and prominent chins. They speak languages you can't understand. They use strange weapons you've never seen. They move in larger groups than you're used to. They're taking your hunting grounds. What do you do? The archaeological record gives us some clues, and honestly, it's not pretty. At sites across Europe and the Middle East, we find bones from both species in the same layers. They were definitely occupying the same spaces, at least sometimes. But were they peaceful neighbours, trading partners, or enemies? Here's where things get dark. There's evidence of violence. Not a ton, but it's there. A Neanderthal skull from Saint-Césaire in France shows a healed fracture from a blow to the head delivered by a sharp implement. Someone hit this person hard enough to crack their skull. They survived, but barely. More disturbing is a rib bone from Shanidar Cave. The bone belonged to a Neanderthal who lived about 50,000 years ago. Embedded in that rib is a wound consistent with being stabbed by a projectile weapon, a throwing spear or a spear launched with an atlatl, the kind of weapon modern humans had perfected, the kind Neanderthals never developed. The wound started to heal, but analysis suggests this person died within weeks, probably from lung damage caused by the puncture. So we have what looks like evidence that a modern human killed a Neanderthal with advanced weaponry. That's not proof of systematic warfare. Not yet. It's one case, one wound. But it makes you wonder, what else happened that didn't leave marks on bone? How many conflicts went unrecorded? Researchers have analysed trauma rates in Neanderthal skeletons and compared them to early modern humans. Surprisingly, both species show similar rates of head trauma and broken bones. Life was incredibly violent for everyone back then. Hunting megafauna with primitive weapons was absurdly dangerous. But the pattern of injuries is slightly different. Neanderthals show more injuries consistent with close quarters encounters, getting gored by an animal at arm's length, taking a hit while wrestling prey to the ground, getting trampled. Modern humans show different patterns, more distance injuries, more projectile wounds. That makes sense because we developed better throwing weapons, atlatls that could launch a dart at 70 miles per hour from 30 yards away. We could kill from a safe distance. In a fight between Neanderthals and modern humans, that's a huge advantage. Neanderthals were stronger, tougher, built like tanks. In hand-to-hand combat, they'd probably win every time. But if modern humans could attack from range, using hit-and-run tactics, staying mobile, never letting them close the distance, the fight tips dramatically in our favor. And there's another critical difference: group size. Genetic analysis suggests Neanderthal populations were small and widely scattered. They lived in bands of maybe 10 to 20 individuals, limited contact between groups, low genetic diversity, signs of inbreeding. Modern humans, on the other hand, traveled in larger groups, 30, 50, sometimes even 100 people. We had more complex social structures, better communication networks, wider trade connections. If conflict broke out, we could field more fighters. So if there was war, and that's still a big if, modern humans had the numbers and the technology. But war doesn't explain everything, not by a long shot, because the genetics tell a completely different story. DNA analysis from Neanderthal bones and from modern humans reveals something absolutely shocking. The two species had sex, a lot of it. New research published in 2024 narrowed down the timing with incredible precision. The main period of interbreeding happened between 47,000 and 43,000 years ago, not earlier, not later. One specific window when Neanderthals and modern humans were living in the same regions, encountering each other regularly and producing hybrid children. Every single person today whose ancestry traces outside of sub-Saharan Africa carries Neanderthal DNA. The percentage varies slightly. East Asians have a bit more, around 2 to 3%. Europeans have about 1 to 2%. People from Southeast Asia have less, but everyone has some. That means at some point, Neanderthal genes got into the modern human gene pool and stuck around for 40,000 years. And here's what's really weird. There's almost no evidence of modern human genes getting into Neanderthal populations. It's basically a one-way street. Scientists have several theories why. Maybe hybrid children born to Neanderthal mothers didn't survive as well. Maybe they were raised in Neanderthal groups and went extinct along with them. Or maybe, and this is darker, maybe modern human women were producing children with Neanderthal men, but not the reverse. Some of those Neanderthal genes we carry today are incredibly important. They affect our immune systems, helping us fight off diseases. They influence metabolism, how our bodies process fats and carbohydrates. Some variants affect skin and hair color. There's even evidence that some Neanderthal genes affect brain structure, though scientists don't fully understand how yet. In many cases, Neanderthal genes helped modern humans adapt to new environments faster than evolution alone would allow. We inherited cold weather adaptations, immune responses to local diseases, genetic variants that made survival in Europe and Asia dramatically easier. But not all Neanderthal DNA was beneficial. A lot of it got selected out over thousands of years. Natural selection weeded out the harmful variants like pulling weeds from a garden. Today, even though all non-Africans have Neanderthal ancestry, the actual amount of Neanderthal DNA in any one person is relatively small. So what does all this interbreeding tell us? It tells us the two species weren't completely separate. They could produce fertile offspring, at least sometimes. They were similar enough biologically that their genes could mix and produce viable children. And that changes everything about how we understand this story. Think about what that must have looked like on the ground, in real life. You're a Neanderthal band moving through southern France. It's late autumn, the herds are migrating south. You know exactly where they'll be because your people have hunted these routes for thousands of years. You reach the valley where you always camp for winter. There's a good rock shelter there, fresh water, a place where your ancestors carved symbols into the stone generations ago. But when you arrive, smoke rises from the shelter. Strange voices echo off the rocks. And when you approach cautiously, you see them. Tall, thin people with unfamiliar faces. They've taken your shelter. What happens next? Maybe you fight. Maybe you negotiate. Maybe you turn around and find somewhere else. Or maybe, if you're desperate or curious or just fundamentally human, maybe something else happens. The genetics suggest that whatever happened, it happened enough times over enough generations that the DNA stuck. We're talking about thousands of successful breeding events over several thousand years. That's not just one or two random encounters. That's sustained contact, regular interaction, some kind of ongoing relationship between the two populations. But here's where things get really interesting and really tragic. While all that mixing was happening, Neanderthal numbers were crashing. Genetic studies of Neanderthal populations show they were never very numerous to begin with. Estimates suggest maybe 10,000 to 70,000 Neanderthals total at their peak across all of Europe and Western Asia. Compare that to modern human populations that might have numbered in the hundreds of thousands. Small populations are incredibly vulnerable. One bad winter could wipe out entire bands. One disease outbreak could devastate a region. One particularly harsh decade could push them to the brink. Neanderthals also showed clear signs of inbreeding. Their genetic diversity was shockingly low. That's dangerous because it means they couldn't adapt quickly to changing conditions. They didn't have enough genetic variation to draw from, and the conditions were changing incredibly fast. Between 50,000 and 30,000 years ago, the climate was wildly unstable. Dramatic temperature swings, sudden shifts in vegetation, ice sheets advancing and retreating. The animals Neanderthals Neanderthals depended on those huge Ice Age beasts, they were struggling too. Some scientists think climate change alone could have pushed Neanderthals to the edge of extinction, but climate doesn't explain why modern humans thrived in the exact same conditions. We actually expanded during those same climatic upheavals. Our populations grew while theirs shrank. That's where competition comes in. Modern humans had advantages that went way beyond just better weapons. We had more sophisticated hunting strategies. We used nets and traps. We fished with hooks and spears. We gathered a much wider variety of plant foods. Our diet was more diverse, more flexible. Archaeological sites show modern humans had trade networks that stretched hundreds of miles. Shell beads from the Mediterranean showing up at sites in Central Europe. Flint from one region being worked at sites far away. That kind of long-distance exchange meant modern humans could buffer against local resource shortages. If one area was experiencing famine, you could trade for food from somewhere else. Neanderthals had some trade, but on a much smaller, more limited scale. Most of their stone tools were made from raw materials found within just a few miles of where they were used. Their social networks were smaller, more isolated, more vulnerable. That isolation might have been their ultimate undoing. Another theory that's gaining serious traction is disease. Modern humans evolved in Africa, the disease capital of the planet. Tropical regions have more pathogens, more parasites, more deadly microbes than anywhere else on Earth. Our ancestors developed immune systems that were battle-tested against an enormous array of diseases. When we left Africa and spread north, we brought those diseases with us, and Neanderthals had never encountered them before. No immunity, no resistance, no evolutionary preparation. It's like what happened when Europeans reached the Americas thousands of years later. Native American populations had been isolated for over 10,000 years. When smallpox and measles arrived with European explorers, it was absolutely catastrophic. 90% death rates in some regions. Entire civilizations collapsed within decades. Could the same thing have happened to Neanderthals? Mathematical models suggest disease could absolutely have been a major factor. When two populations that have been separated for hundreds of thousands of years suddenly come into sustained contact, disease exchange is inevitable, and if one population has a heavier disease load, particularly a tropical disease load, that's a weapon more devastating than any spear or arrow. The models also show something else interesting. At first, when modern humans and Neanderthals initially met, there would have been a disease barrier in both directions. Both groups would have been vulnerable to each other's pathogens. Moving into enemy territory would have been essentially suicidal. That might explain why it took so long for modern humans to really push deep into Europe. We reached the Middle East over 100,000 years ago, but we didn't establish permanent settlements deep in Europe until around 45,000 years ago. What changed? What finally allowed us to break through? The answer might be interbreeding. Hybrid children would have inherited immune genes from both species. As those genes spread gradually through both populations, the disease barrier would have slowly lowered. Eventually, there'd be enough cross-immunity on both sides that migration became possible without immediately dying of disease. But here's the cruel twist. If modern humans started with more diseases to begin with, we'd reach that tipping point first. We'd be able to move into Neanderthal territory while they were still highly vulnerable to our pathogens. And once we did, we'd overwhelm them not with spears and arrows, but with invisible microbes they couldn't fight. It's a genuinely dark thought. The idea that we might have accidentally committed genocide against our closest relatives with diseases we didn't even know we were carrying. But it fits the timeline disturbingly well. Modern humans expand into Europe around 45,000 years ago. Within just 5,000 years, Neanderthals are essentially gone. That's not a lot of time in evolutionary terms. Something dramatic happened, something fast. Could violence have played a role in their extinction? Maybe. Probably, at least to some extent. There's limited but compelling evidence. And we know territorial warfare is extremely common in social predators. Lions fight viciously over territory. Wolves defend their hunting grounds to the death. Chimpanzees, our closest living relatives, wage systematic warfare against neighboring groups. They patrol borders. They launch coordinated attacks. They kill rivals and take their territory. Why would ancient humans be any different? Neanderthals were apex predators. They sat at the top of the food chain. Nothing hunted them except maybe cave hyenas or lions, and even those probably avoided healthy adult Neanderthals. So if their population grew too large for the local resources, conflict with neighboring groups would be inevitable. It's just how territorial predators work. Archaeological evidence shows Neanderthals had clearly defined territories. They returned to the same caves and rock shelters generation after generation. They knew their hunting grounds intimately. Every valley, every river crossing, every seasonal gathering place. When modern humans showed up and started using those same resources, hunting the same herds, occupying the same caves, conflict would have been completely natural. Not because either side was evil or malicious. Just because both groups needed the same things to survive. And in that competition, modern humans had multiple edges. Not because we were necessarily stronger or individually smarter, but because we were more adaptable. We could change our strategies, we could innovate rapidly, we could organize larger groups and coordinate more complex attacks. Some researchers have argued that Neanderthals must have been formidable fighters too. They successfully resisted modern human expansion for tens of thousands of years. If they were pushovers, we would have overrun them immediately. The fact that it took so long suggests they held their ground. They fought back effectively. They won battles. They drove us off. They protected their territory for generation after generation. For thousands of years, neither side could gain a decisive advantage. It was a stalemate. Then something shifted. Something fundamental changed the balance. Maybe it was numbers. Maybe modern human populations finally reached a critical mass where they could simply overwhelm Neanderthal resistance through sheer weight of numbers. Maybe it was technology. The invention of the bow and arrow would have been absolutely game-changing. Suddenly, you could kill accurately at range with incredible power. Or maybe it was social organization. Modern humans had more complex group structures. We could form alliances between different bands. Coordinate attacks involving dozens or even hundreds of people create sustained military pressure that small, isolated Neanderthal groups simply couldn't match. Whatever the reason, between 40,000 and 35,000 years ago, Neanderthals started disappearing. Region by region, their numbers dwindled. The archaeological record shows modern human sites systematically replacing Neanderthal sites. New tools, new art styles, new ways of life spreading inexorably across Europe like a slow wave. But it wasn't a clean, simple replacement. At some sites, we find evidence of overlap and back and forth movement. Layers with Neanderthal tools, then layers with modern human tools, then back to Neanderthal tools again. That suggests there was some back and forth. Some sites changed hands multiple times, territory was contested, and at a few remarkable sites we find something really intriguing. Hybrid tool technologies, stone tools that combine Neanderthal and modern human techniques, as if someone was learning from both traditions simultaneously. That suggests cultural exchange, maybe even cooperation, at least temporarily. At Grotte du Rennes in France, archaeologists found a Neanderthal site with shell beads and bone tools typical of modern human manufacture. For years, scientists hotly debated whether Neanderthals made these themselves or just scavenged them from nearby modern human sites. Recent evidence increasingly suggests they made them themselves. They were copying modern human technology, learning from us, adapting, trying to keep up. That means the relationship wasn't purely war. It was complex and multifaceted. Sometimes they fought, sometimes they traded, sometimes they had sex and produced children, sometimes they learned from each other, sometimes they just avoided each other. The end result, though, was always the same. Neanderthals steadily lost ground. Modern humans steadily gained it. By 30,000 years ago, Neanderthals were almost completely gone. Only a few isolated populations remained, clinging desperately to survival in remote refuges. Places like Gibraltar on the southern tip of Spain, protected by mountains and sea, remote enough that modern humans hadn't fully penetrated yet. Those final Neanderthals held out for maybe another 2,000 years. Then they too vanished from the archaeological record. What was it like being one of the last Neanderthals? Knowing your people were disappearing, watching strangers take over your ancestral hunting grounds? Did they understand what was happening? Did they have stories about the old days when their people were more numerous? Did they mourn the loss? We'll never know, but it's genuinely haunting to think about. The very last Neanderthal who ever lived, someone born around 28,000 years ago. They grew up in a world utterly dominated by modern humans. They probably never met another Neanderthal outside their tiny, dwindling band. They were alone in a fundamental way, the end of their line, and when they died, an entire species died with them. Except not really, not completely. Because of that interbreeding, because of those hybrid children born 45,000 years ago, Neanderthal genes survived, not in their own species, but in ours. It's weird and kind of beautiful when you think about it. Neanderthals went biologically extinct, but they're also still here, living inside us. A ghost population whose DNA literally shapes who we are today. Scientists can now map precisely which parts of the modern human genome came from Neanderthals, and it turns out those genes aren't randomly distributed across our chromosomes. Some regions of the genome have a lot of Neanderthal DNA, other regions have almost none. The regions with virtually no Neanderthal DNA are often genes related to fertility and reproduction. That's a huge clue about what was happening. It strongly suggests hybrid males might have been less fertile or even completely sterile. Like mules, the offspring of horses and donkeys, mules are almost always sterile. They can't reproduce. If male Neanderthal modern human hybrids were sterile or had dramatically reduced fertility, that would have severely limited gene flow. Only hybrid females would successfully pass on Neanderthal genes to future generations. Over thousands of years, most Neanderthal DNA would have been gradually weeded out by natural selection. Only the bits that were actually useful, actually beneficial, would remain, and some of those bits were incredibly useful. Neanderthal immune genes helped modern humans fight off European diseases we'd never encountered before. Genes affecting skin and hair helped us adapt to northern climates faster than evolution alone would allow. One specific Neanderthal gene variant helps people living at high altitudes process oxygen more efficiently. It's common in Tibetan populations. Actually inherited from Denisovans, another human species related to Neanderthals, but the mechanism is the same. Ancient human DNA helping modern humans survive in harsh environments. So in a weird way, absorbing Neanderthal genes made us better adapted to the very regions we were invading. Their evolutionary history, all those thousands of generations adapting to Ice Age Europe, that knowledge got encoded into their DNA. And when we bred with them, we essentially stole that knowledge, downloaded it directly into our genome. It's like a genetic knowledge transfer. Instant adaptation. Does that make what happened less tragic? Not really. An entire species still went extinct, an entire branch of humanity got permanently cut off, but it does complicate the story dramatically, makes it less about us versus them and more about us absorbing them, becoming them in some sense. Some scientists argue Neanderthals didn't really go extinct in the traditional sense. They were assimilated, absorbed into the modern human population through sustained interbreeding, their DNA diluted over time but never completely lost. From that perspective, we didn't kill them, we became them, but that feels like a comfortable lie, a way to avoid confronting the darker implications, because the genetic data is absolutely clear. Gene flow was overwhelmingly one-directional. Modern human genes didn't make it into late Neanderthal populations in any significant numbers. Neanderthal genes made it into us. That means Neanderthal women were having children with modern human men. Those children survived and apparently thrived in modern human communities. But the reverse wasn't happening, or at least not successfully enough to leave a genetic trace. Why? Maybe modern human bands were larger and more welcoming to outsiders. Maybe they absorbed newcomers more easily. Maybe Neanderthal groups were too small, too isolated, too genetically bottlenecked to successfully integrate hybrid children. Or maybe there was violence. Maybe Neanderthal women were taken by force, captured, enslaved. That's an ugly possibility. Nobody wants to think our ancestors did that. But warfare between human groups throughout recorded history has often involved exactly that pattern. Killing the men, taking the women and children. It's one of the darkest constants of human behavior across cultures and time periods. Could modern humans have done that to Neanderthals? Could we have systematically wiped out their males while absorbing their females? The genetics would fit that pattern. It would explain the one-way gene flow. It would explain why Neanderthal populations collapsed while modern human populations exploded. And it would make the story of human expansion significantly darker than most people want to believe. But we don't have proof of that specific scenario, just patterns in the DNA that suggest something profoundly asymmetric was happening, something that benefited modern humans enormously while destroying Neanderthals as a distinct population. Whatever the exact details, the end result was total and final. Within about 10,000 years of sustained contact, Neanderthals were gone, completely extinct as a species. Modern humans, meanwhile, went on to dominate the entire planet. We spread to every continent except Antarctica. We developed agriculture. We built civilizations. We created writing, mathematics, philosophy, art. Eventually, we reached the moon. Everything we've accomplished since, all of recorded human history, all of civilization, happened because we survived and Neanderthals didn't. But before we declare this a simple story of winners and losers, superior versus inferior, let's talk about what makes this incredibly complicated. Because modern science keeps finding things that completely mess with the narrative. In 2024, researchers published a genuinely bombshell study. They sequenced the genomes of Neanderthals who lived around 45,000 years ago, right at the peak of the overlap period, and they found something nobody expected. These Neanderthals had genes that helped them see better in low light, adaptations for surviving brutal cold weather, stronger immune responses to certain European diseases, all stuff scientists figured they'd have, but they also had something else, something surprising, genes related to brain development that were more similar to modern humans than to earlier Neanderthals from thousands of years before. In other words, they were evolving, changing, adapting not just to their environment, but possibly in response to competition with us. That's not a dumb animal going passively extinct. That's a species fighting desperately to survive, using every evolutionary tool available, adapting as fast as biology allows. But here's the tragedy. Evolution is slow, painfully, agonizingly slow. It takes thousands of generations to make meaningful adaptive changes. Neanderthals didn't have thousands of generations. They had maybe 200 generations between first sustained contact and final extinction. Not nearly enough time. Let's talk about their culture for a minute, because this is where things get really emotional and really human. These weren't mindless brutes stumbling around in the darkness. They had rich, complex inner lives. Archaeologists working at Bruniquel Cave in France found something absolutely incredible. Deep inside the cave, over 1,000 feet from the entrance, in total darkness, they discovered circular structures made from broken stalagmites. 2 rings carefully constructed, organized deliberately, purposeful. The structures were dated to 176,000 years ago, way before modern humans reached Europe. Only Neanderthals were there at that time. Why would they build these structures? Were they meeting places, ritual sites, ceremonial spaces? We honestly don't know. But somebody spent hours in complete darkness, methodically breaking off stalagmites and arranging them in precise geometric patterns. That's abstract thought. That's symbolic behavior. That's purpose beyond immediate survival needs. At other sites across Europe, we find even more evidence of Neanderthal culture and sophistication. They used pigments, red ochre and black manganese. They ground these minerals into fine powder and applied them to shells, to bones, maybe even to their own bodies for decoration. Why? Decoration, communication, ritual, identity. Again, we don't know for sure, but the behavior itself tells us something profound and undeniable. They cared about more than just food and shelter and survival. They wanted to make things beautiful. They wanted to mark themselves as different from the animals they hunted. That's deeply, fundamentally human behavior. And then there's the critical question of language. Did Neanderthals talk? Could they communicate complex ideas through speech? For a long time, scientists argued they couldn't. Their vocal anatomy was supposedly too different. Their brains supposedly lacked the right structures. They were supposedly limited to grunts and gestures and simple vocalizations. But DNA evidence changed everything. Neanderthals had the exact same version of the FOXP2 gene that modern humans have. That's the gene most closely associated with speech and language development. Mutations in FOXP2 cause severe speech and language problems in modern humans. If Neanderthals had the same functional gene, they almost certainly could speak. Maybe not with the exact same complexity as us. Maybe their vocal range was slightly more limited. Maybe their grammar was simpler. But they had language. They could communicate verbally, they could share information through words. What did they talk about? What stories did they tell around fires on cold winter nights? What names did they call themselves? What songs did they sing? What jokes did they make? We'll never, ever know. But it's heartbreaking to think those voices are lost forever. An entire language family, thousands of years old, spoken by tens of thousands of people over hundreds of generations, gone, erased, not a single word preserved, not a single phrase remembered. When you really think about that, the extinction of Neanderthals becomes more than just a biological event. It's a cultural genocide, the death of an entire way of seeing the world. Every Neanderthal who ever lived had thoughts, dreams, fears, hopes. They watched sunsets and wondered what they meant. They mourned their dead and felt genuine grief. They probably laughed at things they found funny. They definitely felt pain and fear. And we, Homo sapiens, we're directly or indirectly the reason they're gone. Whether through violence, disease, competition, or just overwhelming demographic pressure, we pushed them into extinction. That's deeply uncomfortable to sit with, but it's important because it tells us something fundamental about ourselves, about what we're capable of. We like to think we're special, that we're fundamentally different from other species, that we're moral, ethical, capable of deep empathy and compassion. But when push came to shove, when it was us versus them, when resources were limited and survival was on the line, we didn't hesitate. We took what we wanted. We expanded into their territory. We out-competed them for resources. And when they couldn't keep up, we let them die. Some of us had sex with them along the way. Some of those encounters might have been genuinely consensual. Some definitely weren't. And then, after they were gone, we forgot about them completely. For thousands of years, we had absolutely no idea they'd ever existed. Until 1856, when workers in Germany's Neander Valley found strange bones in a cave. Bones that didn't quite look human, but also weren't from any known animal. That discovery changed everything. Suddenly, we had to confront the uncomfortable fact that we weren't alone. That other intelligent species had walked the earth, that we'd shared the planet with close relatives we'd helped destroy. The more we learn about Neanderthals through archaeology and genetics, the more human they become, and the more their extinction looks like something we should genuinely feel guilty about. But guilt doesn't change what happened. They're still gone. We're still here. So what does that mean for how we think about ourselves? Some researchers argue that studying Neanderthals is really about understanding human nature at its core, about recognizing that capacity for violence, for genocide, for systematically erasing the other has always been part of who we are. Throughout recorded history, humans have committed terrible atrocities against other human groups, different ethnicities, different religions, different tribes, different nationalities. We've enslaved each other, massacred each other, tried repeatedly to wipe each other out completely. If we could do that to our own species, to people who are genetically almost identical to us, doing it to a different species, even a closely related one, would have been much easier. The Neanderthal extinction might be the very first genocide in human history, but it definitely wasn't the last. That's an incredibly dark lens to view our past through, but maybe it's necessary. Maybe understanding what happened 40,000 years ago can help us avoid repeating those same patterns now and in the future. Because here's the thing, humans today are incredibly diverse genetically, culturally, linguistically, but we're all the same species, all Homo sapiens. There are no Neanderthals left to compete with, no Denisovans, no Homo erectus, no other human species. We're alone, the only human species left standing, and that loneliness, that singularity is entirely our own doing. Now let's flip the script for a second, because there's another way to look at this whole story, a less dark interpretation. Maybe what happened wasn't genocide at all. Maybe it was merger, integration, two species coming together and becoming something genuinely new. Think about it carefully. Modern humans today aren't genetically pure Homo sapiens. We're hybrids. A complex mix of African Homo sapiens and Eurasian Neanderthals, with a bit of Denisovan thrown in for some populations. We're literally the biological product of interspecies mixing. Our genomes are living evidence of tens of thousands of encounters between different human species over thousands of years. Some violent, sure, but some must have been peaceful. Some must have been based on genuine connection, maybe even love, because you can't maintain sustained gene flow over thousands of years through violence alone. At some point, hybrid children had to be accepted into communities, raised, protected, taught, integrated. That takes tolerance. It takes openness to difference. It takes seeing past physical differences and recognizing shared humanity. So maybe the real story isn't that we destroyed them through violence and disease. Maybe it's that we absorbed them, made them part of us, preserved the best, most useful parts of their genome and carried it forward into the future. From that perspective, Neanderthals didn't really go extinct. They transformed, evolved, merged with a larger, more successful population. It's still sad that we lost their unique culture, their distinct way of life, their particular perspective on existence. But at least something of them survived. You can see this pattern playing out clearly in the genetic data. Certain Neanderthal genes are incredibly common in modern populations, not just present by chance, but actively maintained by natural selection over thousands of years. Take immune system genes, for example. When modern humans first moved into Europe and Asia, they encountered completely new diseases, pathogens they'd never faced in Africa, viruses and bacteria they had zero immunity against. Neanderthals had been dealing with those exact diseases for hundreds of thousands of years. They'd evolved sophisticated resistances through brutal natural selection. By breeding with Neanderthals, modern humans instantly acquired those resistances. It was like downloading antivirus software directly into our genome. Suddenly we could survive in environments that would have killed us otherwise. That's not genocide, that's synergy. Two species combining their respective strengths to create something more adaptable than either was alone. The exact same thing happened with cold weather adaptations, genes affecting skin tone, hair thickness, metabolic rate, fat distribution. Neanderthals were optimized for Ice Age Europe through hundreds of thousands of years of evolution. Modern humans from Africa weren't at all, but hybrid children got the best of both worlds. Over many generations, natural selection favored people with the right mix of genes for their specific environment. In northern regions, more Neanderthal genes stuck around. In tropical regions, fewer survived. That's real-time adaptation happening through genetic mixing. So in a very real sense, Neanderthals aren't extinct. They're dormant, scattered across the genomes of billions of humans, waiting in our DNA. Every time a human baby is born outside Africa, there's a chance they'll inherit specific Neanderthal traits. The shape of their skull, the structure of their immune system, the way their brain processes certain types of information. Neanderthals live on through us. We're their descendants just as much as we're descended from African Homo sapiens. That completely reframes the entire story, makes it less about extinction and more about evolution and transformation. Not the end of a species, but a profound transformation into something new. But even that gentler interpretation has serious problems, because the archaeological record is brutally clear. Neanderthal sites disappear from the landscape. Their distinctive tool technologies vanish completely. Their unique way of life ends permanently. Yes, their genes survived in diluted form, but their culture didn't. Their languages didn't. Their stories didn't. Their knowledge didn't. And culture is what makes us human. Culture is what gives life meaning beyond mere biological survival. If an alien species came to Earth tomorrow and wiped out all humans but preserved tiny fragments of our DNA in their own genome, would that count as humanity surviving? Would we be okay with that? Probably not. Because what makes us human isn't just our genes, it's our stories, our art, our languages, our music, our accumulated knowledge passed down carefully through generations. All of that died permanently with the Neanderthals, and no amount of preserved DNA can ever bring it back. So we're left with a complicated, messy, deeply unsatisfying story. Not good guys versus bad guys. Not a simple tale of primitive beings being replaced by advanced ones. Just two groups of humans, different but fundamentally related, competing desperately for the same resources in a harsh, unforgiving world. One group happened to have advantages the other couldn't match. Larger populations, slightly better weapons, more flexible social structures, better long-distance communication, and maybe, just maybe, a heavier disease load that functioned like unintentional biological warfare. The other group, equally intelligent and equally human, fought back. They adapted as best they could. They tried desperately to survive. They succeeded for a while. They even contributed their genes to the winning side. But in the end, they lost. Their unique identity was erased, their culture forgotten, their species extinct. It's not a satisfying story at all. There's no clear moral, no lesson that makes it all make sense, no way to feel good about what happened, just the brutal, indifferent reality of evolution and competition. The same forces that created all life on Earth also drove countless species to extinction. Neanderthals were just one more casualty in that endless process, except they weren't just any species, they were us, our closest relatives. close enough to breed with, close enough to share dreams and fears and hopes. And we let them die, or we absorb them, or both simultaneously. Maybe that's the real lesson here, that the line between destruction and integration is much thinner than we want to believe, that the same processes can be both genocide and evolution depending entirely on how you look at them. That's deeply uncomfortable, but it's honest. And if we're going to understand what really happened 40,000 years ago, we need to be completely honest, even when it makes us look bad. Especially when it makes us look bad. Because the story of Neanderthals isn't ancient history, it's a mirror, showing us what we're capable of, both the good and the bad. We're capable of incredible empathy, of caring for the weak and injured, of making art and music and meaning out of chaos. But we're also capable of incredible violence, of seeing others as less than human, of taking what we want regardless of the cost to others. Those two sides of human nature have been with us since the very beginning, since before we were even fully Homo sapiens, since we were sharing the earth with our Neanderthal cousins. And they're still with us right now. So when we ask what really happened between Neanderthals and us, maybe the truest answer is simply that we were human, in all the complicated, contradictory, beautiful and terrible ways that implies. There's a specific moment in this story that changes everything. A particular time and place where the balance of power shifted irrevocably, and scientists think they've found it. The Levant, that narrow strip of land connecting Africa to Eurasia. Modern-day Israel, Lebanon, Syria, Palestine. 45,000 years ago, this was the frontier. The collision zone where two human species met face to face on a massive scale for the first time. Before this moment, interactions were sporadic and limited, small groups occasionally encountering each other, trading a few genes, but not much else. The genetic evidence shows earlier contacts going back over 100,000 years, but those were blips. Brief encounters in the vastness of time. This was fundamentally different. This was sustained, ongoing contact. Thousands of people from both species living in overlapping territories, hunting the same animals, competing for the same caves and water sources. And something critical happened there, something that set the stage for everything that followed. Mathematical models of disease transmission suggest that for tens of thousands of years, there was an invisible barrier, a disease standoff. Neither species could successfully invade the other's core territory because both would get devastatingly sick. Neanderthals carried European and Asian pathogens modern humans had no immunity to. Modern humans carried African diseases Neanderthals had never encountered. The Levant became a buffer zone, a narrow strip where both populations could coexist uneasily, but neither could advance into the other's heartland. Like two armies facing each other across a demilitarized zone. But then, something fundamental shifted. The barrier started breaking down. Why? Almost certainly because of interbreeding. Every hybrid child born was a tiny bridge across the disease divide. They inherited immune genes from both parents. If they survived childhood, which many probably didn't, they'd be resistant to diseases from both populations. And their children would pass those resistances on. Over hundreds of generations, immunity spread, slowly at first, then faster and faster, eventually reaching a critical tipping point where the disease barrier collapsed entirely. Once that happened, modern humans could push forward, deep into Neanderthal heartland, into Europe, and they did. Around 45,000 years ago, modern humans with sophisticated Upper Paleolithic technology start showing up deep in Europe. France, Germany, Britain, places Neanderthals had controlled for hundreds of thousands of years. The invasion had truly begun, but Neanderthals didn't just passively accept this. The archaeological evidence shows they fought back hard, not with organized armies or warfare in the modern sense, but with everything they had. At some sites, we see Neanderthals rapidly adopting modern human technologies, copying our blade-making techniques, creating similar types of tools, mimicking our innovations. That's not surrender, that's adaptation, that's trying desperately to keep up with competitors who had better technology. It's actually genuinely impressive when you think about it. These weren't stupid creatures blindly following tradition until they died out. They could recognize when others had superior tools and learn to replicate them. That takes real intelligence, creativity, problem-solving ability. But it wasn't enough. It couldn't be enough. Here's why. The problem wasn't just technology, it was demographics. Cold, brutal demographics. Modern humans were producing children faster than Neanderthals could replace their dead. Our population was growing steadily, theirs was slowly shrinking. Even without any direct violence, even if every single interaction was perfectly peaceful, the math was inexorably against them. Think about it like this. If a Neanderthal band had 10 people and lost 2 in a particularly hard winter, they'd lost 20% of their entire population. That's absolutely devastating. It might take an entire generation to recover those numbers. A modern human band of 50 people losing 2, that's only 4%, barely noticeable, easily replaced within a year or two. And with more people, there were more potential parents to make up the difference quickly. Over time, those percentages compound dramatically. Modern human populations grew exponentially. Neanderthal populations stagnated or actively declined. Eventually, we simply outnumbered them by such massive margins that we overwhelmed them, pushed them into smaller and smaller territories. The genetic data backs this up perfectly. Analysis of Neanderthal DNA shows they went through multiple severe population crashes, bottlenecks where their numbers dropped dramatically. They'd recover somewhat, but never fully. Each crash left them more vulnerable than before. Modern humans, meanwhile, were expanding rapidly. Our genetic diversity was increasing. We were forming larger and larger social networks, spreading our genes across wider geographic areas. That's the fundamental advantage of large numbers. More people means more genetic diversity, more collective brain power, more innovation, more chances for useful random mutations to arise and spread. Neanderthals never had that luxury. Their small, isolated populations meant severely limited genetic mixing, higher rates of inbreeding, less diversity to draw from when conditions suddenly changed. When a new disease swept through, when a climate shift reduced prey populations, when a particularly brutal winter killed off the elderly and the very young, Neanderthal bands might not have enough survivors left to maintain their culture, to pass on crucial knowledge to the next generation. Anthropologists call this the Toba catastrophe problem, named after a volcanic eruption that supposedly nearly wiped out humanity. Small populations are incredibly vulnerable to random disasters. One bad break can be the permanent end. Neanderthals faced bad breaks constantly, and each one left them weaker, But there's another factor we haven't fully explored yet. One that might be even more important than disease or demographics. Language. Not whether Neanderthals could physically speak. We've established they probably could, but how complex was their language? How many concepts could they express verbally? How effectively could they transmit accumulated knowledge across generations? This is where differences in brain structure become absolutely crucial. Remember those differences we talked about? Neanderthals having larger visual processing areas but smaller frontal regions. The frontal regions of the brain, especially areas like Broca's area and Wernicke's area, are critical for language processing, for complex grammar, for abstract thought expressed through words. Modern human brains have these areas in abundance. Our frontal lobes are absolutely massive compared to any other primate. That's what allows us to have incredibly complex languages with elaborate grammatical structures, thousands of words, nested clauses, conditional statements, abstract concepts. Could Neanderthals do the same? Maybe, but maybe not at the exact same level of complexity. If their language was simpler, more limited in vocabulary and grammatical structure, that would have enormous implications, because language isn't just about communication, it's about thinking itself. The words we have literally shape the thoughts we can think. If you don't have a word for tomorrow, planning for the future becomes significantly harder. If you don't have terms for abstract concepts like justice or possibility or probability, those ideas become difficult to reason about systematically. A less complex language would mean less complex culture, simpler stories, less elaborate teaching methods, reduced ability to pass on accumulated knowledge efficiently, and in competition with a species that could communicate virtually everything, that could teach complex skills efficiently through detailed verbal instruction, that could coordinate large group actions through sophisticated planning, you'd be at a massive, insurmountable disadvantage. This might explain why Neanderthal technology stayed relatively static for tens of thousands of years, while modern human technology exploded in diversity and sophistication after we left Africa. It's not that Neanderthals couldn't innovate at all. They clearly could, but they couldn't transmit those innovations effectively across time and space. Each generation had to painstakingly relearn what the previous generation knew. Progress was slow, inefficient, prone to knowledge loss. Modern humans with more complex language could build systematically on the past, stand on the shoulders of giants, each generation adding to what came before. Over thousands of years that compounds, it leads to exponential growth in knowledge and capability, and that's probably what doomed the Neanderthals more than anything else. Not any single weakness, but accumulated disadvantages across multiple domains, slightly worse communication, slightly smaller populations, slightly less adaptable immune systems, slightly more conservative territorial behavior. Any one of those disadvantages might not have mattered much, but together they were absolutely fatal. There's an important anthropological concept called competitive exclusion. It says that two species competing for exactly the same resources in exactly the same ecological niche cannot coexist indefinitely. Eventually, inevitably, one will outcompete the other. Even tiny advantages compound over time until one species completely dominates and the other goes extinct. That's precisely what happened to Neanderthals. They were too similar to us, occupied the same niche, hunted the same prey, used the same caves and rock shelters. There simply wasn't room for both species long term, and we had just enough of an edge to win. It probably wasn't obvious at first. Early on, during those thousands of years in the Levant, things might have seemed relatively stable, both species coexisting, neither gaining significant ground. But the math was always against Neanderthals. Every year, their relative numbers declined just a little bit. Their genetic diversity decreased fractionally. Their range contracted slightly. By the time it became obvious what was happening, it was far too late. They didn't have the population size to mount effective resistance, didn't have the genetic diversity to adapt fast enough, didn't have the communication skills to coordinate an effective response. They were in a death spiral, and there was no way out. Some of them must have known. In those final generations, the last Neanderthals living in southern Europe must have realized on some level that they were disappearing. Fewer and fewer bands, longer and longer distances between groups. Harder and harder to find mates outside your immediate family. Did they understand they were going extinct? Did they have conceptual frameworks for species death? We don't know. We can't know. But it's a haunting thought. The last generation of Neanderthals watching their world systematically shrink, knowing on some deep, intuitive level that they were the end of the line. And what about us, the modern humans who were there? Did we know we were witnessing the death of another human species? Almost certainly not. To them, Neanderthals were just other people. Different, sure, strange looking, but people nonetheless. They probably didn't have a concept of species in the modern scientific sense. They just knew that those other people, the ones with heavy brows and powerful builds, were becoming increasingly scarce, disappearing from their traditional territories, eventually gone altogether. Maybe they told stories about them afterwards, the strange, powerful people with unusual faces, the ones who used to live here but don't anymore. Those stories, if they existed at all, didn't survive. No oral tradition can possibly last 40,000 years. Everything about Neanderthals was completely forgotten until we literally dug up their bones. But for a while, in those final precious centuries of overlap, humans of both species lived side by side. Saw each other regularly, knew each other as individuals, maybe even cared about each other. Some definitely had sex. Those encounters, whether forced or consensual, whether based on love or desperation or simple opportunity, created children who carried both species' DNA forward. They're the only reason we know Neanderthals existed at all, apart from fossils. Without that genetic evidence preserved in our own bodies, we might have thought Neanderthals were just another variant population. Variation within our species rather than a separate species entirely. But the DNA doesn't lie. The differences are too great, too systematic, too consistent. These were genuinely distinct evolutionary lineages, separated for hundreds of thousands of years, and yet still similar enough to produce viable offspring. That's the profound paradox at the heart of this entire story. Different enough to be separate species, similar enough to mix. Where do you even draw the line? When does variation within a species become the formation of a new species? The answer isn't clean or simple. Biology is fundamentally messy. Evolution doesn't care about our neat taxonomic categories. Neanderthals and modern humans existed in that fuzzy zone. Diverged, but not completely. Different, but not incompatible. Separate evolutionary paths that could still intersect. If things had gone differently, if environmental conditions had favoured Neanderthals instead of us, we might be the ones who went extinct. They might be the ones writing documentaries about the strange, flat-faced humans who used to live alongside them. But history doesn't have alternate timelines. There's only what actually happened, and what happened is that we survived and they didn't. Now we're left trying desperately to understand why, trying to piece together the story from fragments, bones and stones and genes. The archaeological equivalent of reconstructing a murder from a crime scene 40,000 years cold. We'll probably never know the complete truth. Too much is permanently lost to time. Too many details erased by millennia of wind and rain and geological upheaval. But we know enough to see the broad strokes clearly. Enough to understand that what happened was complicated, not good or evil, not right or wrong, just survival, just competition, the same forces that have shaped all life on Earth since the very beginning. And maybe that's the most important lesson, that we're not separate from nature, not above it, not exempt from its rules. We're products of it, subject to the exact same evolutionary pressures as every other species that's ever existed. We like to think we're special, that human morality and culture lift us above mere animal competition. But 40,000 years ago, when it truly mattered, when survival itself was on the line, we competed just like any other species, and we won. Let's zoom in on one specific moment, one specific place where we can see the human drama playing out with heartbreaking clarity. Saint-Césaire, France. 36,000 years ago, a Neanderthal lived and died here. The bones were found with Châtel-Perronian tools. That transitional technology that combines Neanderthal and modern human elements. This person's skull shows something deeply chilling, a healed fracture. Someone hit them in the head with enough force to crack bone. The wound healed but left permanent damage. They survived the attack. But here's the haunting question. Who attacked them? Another Neanderthal in some internal dispute, or a modern human? We can't know for certain, but the timing is suggestive. This is precisely when modern humans were pushing aggressively into the region. Right when competition for resources would have been most intense. If it was a modern human who struck that blow, we're looking at direct evidence of violence between species. Not war, not organised conflict, just one desperate moment where two different kinds of human came face to face and things got ugly. That's the reality of what was happening across Europe. Not grand battles, not orchestrated campaigns, just small-scale conflicts over hunting grounds, over caves, over water sources. The same petty violence that has characterised human behaviour throughout all of recorded history, except this time it was between species, and it adds up. Enough individual conflicts over enough generations in enough places and you get extinction, death by 1,000 cuts. But violence alone doesn't explain the complete collapse. Remember, Neanderthal populations had survived successfully for hundreds of thousands of years. They'd been through dramatic climate changes before. They'd competed with other dangerous predators. They were ultimate survivors. So why did they fail this time? The answer might lie in something we haven't talked about much. Social learning, cultural transmission, how knowledge gets passed down through generations. Modern humans absolutely excel at this. We're the ultimate cultural species. We don't just learn from individual experience. We learn from everyone around us, from previous generations, from people we've never even met. We accumulate knowledge over time. This is called cumulative cultural evolution. Each generation adds to what came before. Over time, you get exponential growth in skills, technologies, strategies. Neanderthals had culture too, absolutely. They made sophisticated tools, they had traditions. But did they have cumulative cultural evolution at the same level? The archaeological record strongly suggests maybe not. Neanderthal tool technology remained relatively stable for tens of thousands of years. Mousterian tools from 200,000 years ago look remarkably similar to Mousterian tools from 50,000 years ago. Modern human technology, by contrast, changed rapidly. Upper Paleolithic tools show tremendous variation and constant innovation over much shorter time periods. New tool types appearing, old ones being refined. Constant experimentation. That suggests modern humans were significantly better at social learning, better at transmitting complex information, better at building systematically on past knowledge. And that's a huge advantage in competition. If you can learn from the successes and failures of everyone who came before you, you can avoid mistakes, optimize strategies, invent new solutions to old problems. Neanderthals, with more limited social learning, had to rediscover things each generation. Less efficient, slower progress, more vulnerability to environmental changes. Here's a concrete example. Both species hunted large, dangerous game. Mammoths, bison, reindeer, dangerous animals that could easily kill you if you made one wrong move. Neanderthals hunted up close with thrusting spears, getting within arm's length of their prey. It worked, obviously, but it was incredibly, absurdly risky. The trauma patterns on Neanderthal bones show they got injured constantly. Broken bones, crushed skulls, gored by tusks and antlers. They were tough enough to survive these injuries often enough to pass on genes, but barely. And their hunting success probably varied wildly depending on luck. Sometimes they'd make kills, sometimes they'd go hungry for days. High risk, inconsistent reward. Modern humans developed different strategies, throwing spears with atlatls, eventually bows and arrows. These technologies allowed us to kill from safe distance, much safer, more consistent, dramatically lower injury rates. But more importantly, these complex technologies required extensive teaching. You can't figure out how to make an atlatl just by looking at one. You need someone to show you, explain the technique carefully, correct your mistakes, provide feedback. That kind of detailed teaching requires complex language, patience, social structures that support extended learning periods. If Neanderthals didn't have that, or had it to a lesser extent, they couldn't adopt these new technologies as easily, couldn't keep pace with the innovation. So over time, the gap widened inexorably. Modern humans got better tools, better strategies, more efficient hunting, higher success rates, healthier populations. Neanderthals stayed with what they knew: thrusting spears, close quarters hunting, higher injury rates, more people dying young, population growth slowing or stopping entirely. The math is absolutely brutal. Even small differences in hunting success compound dramatically over generations. If modern humans could feed their children just 5% more reliably, that translates to slightly better child survival rates, which means slightly more people reaching reproductive age, which means slightly faster population growth. Do that for 1,000 years and the population differences become staggering. Add in everything else we've talked about: disease, social learning differences, group size, communication complexity, all these tiny advantages stacking and multiplying, and you get extinction. But here's something that makes it even more tragic. Neanderthals weren't stupid. They knew modern humans had better technology. They actively tried to adapt. At multiple sites across Europe, archaeologists find Neanderthal contexts with tools that look remarkably like modern human designs: blade technologies, bone tools, personal ornaments like beads and pendants. For a long time, scientists hotly debated whether Neanderthals made these themselves or just scavenged them from modern human sites. The question matters enormously because it tells us about their cognitive abilities and adaptability. Recent evidence increasingly suggests they did make them themselves. They were learning from us, copying our techniques, trying desperately to match our innovations. That's not the behavior of a species that's somehow inferior or doomed by stupidity. That's the behavior of intelligent beings fighting for survival, adapting as best they can with the tools available. But it wasn't enough, because innovation requires more than just copying. It requires understanding underlying principles, being able to modify and improve designs, coming up with new applications. Neanderthals could copy, but could they innovate at the same rate as us? The evidence suggests not quite. Their versions of modern human tools are often cruder, less refined, missing key features. It's like they got the general idea, but couldn't quite grasp all the details. Or they didn't have the social structures to support the lengthy apprenticeships needed to truly master complex technologies. Either way, they were always playing catch-up, and in evolution, being one step behind is eventually fatal. There's a modern analogy that works well. Imagine two companies competing in exactly the same market. One has a huge R&D budget, extensive training programs, massive scale. The other is smaller, more isolated, less able to invest heavily in innovation. The small company might make perfectly good products, might even copy the big company's designs pretty well. But over time, inevitably, the big company pulls ahead. Economies of scale, better resources, more brain power applied to problems. Eventually, the small company goes bankrupt. Not because they were fundamentally incompetent, just because they couldn't keep pace. That's what happened to Neanderthals, outcompeted by a rival with systemic advantages they simply couldn't overcome. And there was nowhere to retreat to, no untapped markets, no unexplored territories where they could rebuild and start over. Modern humans were everywhere, spreading across the old world like wildfire. By 30,000 years ago, Neanderthals were down to their last refuges. Southern Spain, Gibraltar. Isolated pockets where geography provided some temporary protection from the modern human onslaught. But even those didn't last long. The final Neanderthal populations disappeared around 28,000 years ago, not with a bang, just fading away quietly. Births failing to replace deaths. Groups too small to find mates outside their immediate family. Genetic diversity collapsing entirely. The last Neanderthal who ever lived probably died alone or nearly alone, maybe in a small band of 3 or 4 individuals, the last remnants of a species that once numbered in the tens of thousands. Did they know they were the last? Did it matter to them emotionally? We'll never know. But it's impossible not to feel something thinking about it. Empathy, sadness, recognition of shared humanity. Because they were us, not metaphorically, literally the same genus. Close enough to breed, close enough that their genes live on in billions of humans today. When they died, part of us died too. And here's the really messed up part. We didn't learn from it at all. Throughout all of recorded history, humans have continued doing the exact same thing to each other, wiping out rival groups, committing genocide against populations that look or sound different, the capacity for violence, for seeing others as less than human, for competition without mercy. That didn't die with the Neanderthals. It's still here, still active, still shaping human behavior. Every genocide, every ethnic cleansing, every systematic attempt to erase another group of people, it echoes what we did to the Neanderthals. The difference is now we're doing it to our own species, to people who are genetically almost identical to us, people who speak languages we could learn, who have cultures we could understand if we tried. We don't even have the excuse of species difference anymore, just hatred, fear, competition for resources, the exact same dynamics that drove Neanderthals to extinction. Maybe that's the real lesson here, not that we're better than Neanderthals, not that we're smarter or more deserving of survival, just that we're more successful at competition. And success in nature is completely amoral. It doesn't care about fairness or justice. It only cares about survival, about reproduction, about passing on genes. And in that brutal calculus, we won. Neanderthals lost. End of story. Except it's not the end at all, because those Neanderthal genes we carry around, they're not passive, they're active, affecting our biology right now. Today, some of those genes help us enormously, boosting immune function, helping us adapt to different climates, contributing to traits that are useful in modern environments, but some of them might actually hurt us. Recent research suggests Neanderthal genes are linked to increased risk for certain diseases, depression, addiction, autoimmune disorders, certain types of cancer. That makes biological sense because those genes evolved in a completely different context. Ice Age Europe, tiny populations, different diets, different stresses, different pathogens. When you transplant those genes into modern environments, into populations of billions, living in cities, eating processed food, they might not work as well. They might even cause serious problems. So in a weird way, the story of Neanderthals isn't over at all. It's ongoing, playing out in hospital rooms and research labs across the world. Every time scientists discover another Neanderthal gene variant associated with disease or health, that's the ancient past reaching into the present, affecting us, shaping us. We can't escape them. Can't leave them behind in history. They're woven into our DNA, part of what makes us who we are. And maybe that's appropriate. Maybe that's a form of justice. The species we helped destroy lives on inside us, shaping us, influencing us, reminding us, whether we like it or not, that we're not alone in the human family tree. We never were. We're hybrids, products of mixing. Our genome is a living record of ancient encounters between different kinds of human. That should humble us profoundly, should make us think twice before dividing humanity into us versus them, because genetically, there's no pure us. There's only mixing. There always has been. The idea of racial purity, of ethnic separateness, it's a complete lie, a fiction. Humans have always mixed, always absorbed genes from wherever we could find them. Neanderthals are just the most dramatic, well-documented example, but the pattern repeats throughout history. Populations encountering each other, mixing, creating new combinations. That's the human story, not separation, not purity, but endless, messy, complicated mixing. And acknowledging that, accepting it, maybe that's how we honor the Neanderthals, by recognizing that their legacy isn't extinction, it's us. Now let's talk about what modern science can actually tell us with precision, because in the last 20 years, our understanding of Neanderthals has absolutely exploded. We're not just digging up bones anymore, we're reading their DNA. reconstructing their complete genomes, comparing them to ours base pair by base pair. And what we're finding is genuinely stunning. In 2024, researchers published a paper analysing ancient DNA from early modern humans who lived 45,000 years ago. These people were alive right at the peak of the overlap period with Neanderthals, and their genomes tell an incredible story. These early Europeans had way more Neanderthal DNA than we do today, up to 9% in some individuals. Compare that to the 1 to 4% in modern populations. That's a massive, dramatic difference. What happened? Why did so much Neanderthal DNA disappear from our genomes? Natural selection. Over thousands of years, harmful Neanderthal genes got systematically weeded out, removed from the population because they reduced survival or fertility. But here's what's wild. The process is still ongoing. Even today, natural selection is still actively removing Neanderthal DNA from human populations. Slowly, gradually, but measurably. Scientists can track this by comparing Neanderthal gene frequencies across time. DNA from ancient humans versus DNA from people living today. The difference shows which genes are being selected against. And a clear pattern emerges. Neanderthal genes in certain regions of the genome disappear faster than others. Specifically, genes related to brain development and testicular function. The brain genes make sense. Neanderthal brains were organized differently than ours. Genes that affect brain structure might not work well in modern human neural development, might cause subtle problems, so they get selected out over time. The testicular genes are even more interesting. They strongly suggest hybrid males had fertility problems, maybe not complete sterility like mules, but significantly reduced fertility. That would perfectly explain the one-way gene flow. If hybrid males couldn't reproduce well or at all, only hybrid females would successfully pass on Neanderthal genes to future generations. Over time, you'd see exactly what we see in the data. Neanderthal mitochondrial DNA disappearing completely because mitochondria are inherited only maternally, but nuclear DNA persisting because females could reproduce successfully. It's a subtle form of reproductive isolation, not complete, but enough to limit gene flow, to keep the two species mostly separate even when they were living side by side. And it means the hybrid children, those bridges between species, they weren't normal. They probably weren't as healthy. They were probably less fertile, maybe shorter lived, maybe had health problems we can't detect in bones. Being a hybrid was hard. Most didn't make it to adulthood. Only a small percentage survived and reproduced, but those who did, their genes spread. And here we are. So what does this mean for how we think about Neanderthals and modern humans as separate species? The classical biological species concept says two populations are different species if they can't produce fertile offspring. Horses and donkeys are different species because their offspring, mules, are sterile. But Neanderthals and modern humans could produce fertile offspring, at least fertile daughters. Does that make us the same species? Not really, because the definition is messier than simple textbooks suggest. Lots of species can hybridize and produce at least some fertile offspring. Lions and tigers, wolves and coyotes, different species of bears. Hybridization doesn't mean they're not separate species. It just means the barrier between them isn't complete. There's some gene flow, but not enough to merge them into one population. That's what happened with us and Neanderthals. Some gene flow. But the population stayed distinct until one went extinct. Now scientists are using ancient DNA to ask even weirder questions, like what did Neanderthals actually look like? Not their skulls, their soft tissues, their skin, hair, eyes, and the answers are genuinely surprising. Some Neanderthals had red hair, not the same genetic mutation that causes red hair in modern Europeans, but a different variant that produced a similar reddish colour. So independently, both species evolved redheads. Some probably had pale skin, an adaptation to low sunlight conditions in northern Europe. You need pale skin to synthesize vitamin D efficiently when there's not much sun. Others might have been darker skinned. Neanderthals were spread across a huge geographic range from Spain to Siberia. They probably showed variation in skin tone just like modern humans do across different latitudes. We can even start to guess at things like eye colour, hair texture, body odour, because all of these traits are influenced by genes we can now sequence and compare. Some Neanderthals probably smelled different than modern humans. Different variants of genes, controlling sweat gland function and pheromone production. If you met one face to face, you'd probably notice the smell before anything else. Strange but not entirely unfamiliar, and they might have noticed our smell too. Different but recognizable. Close enough to be disturbing. This is the stuff that really brings them to life, not just bones and tools, but actual physical beings with specific appearances, people you could have looked in the eye and seen personhood staring back. And some modern humans did exactly that, looked Neanderthals in the eye, saw people, and decided to sleep with them. That's what the genetics prove beyond doubt. These weren't all violent encounters. At least some of them were consensual, maybe even loving. Imagine being a Neanderthal woman meeting a modern human man. He looks different, talks different, uses strange tools, but he's strong, capable, maybe attractive in ways you don't fully understand. Do you see him as human, as a potential mate, or as something fundamentally other? The genetics say at least sometimes the answer was yes. These two people from different species saw enough similarity to form connections, to have children together, and those children grew up in one community or the other, learned languages, participated in culture, became part of the ongoing human story. That's beautiful in a way. Love, or at least attraction, crossing species boundaries, connection overcoming difference, but it's also tragic because those connections weren't enough to save Neanderthals. Despite interbreeding, despite cultural exchange, despite what must have been thousands of individual relationships over thousands of years, they still went extinct. Love wasn't enough. Understanding wasn't enough. Even genetic mixing wasn't enough. Numbers were enough. Technology was enough. The cold, indifferent calculus of competition was enough. And now we're left with this weird situation where Neanderthals are both extinct and not extinct simultaneously. Their species is gone, but their genes remain. Living zombie DNA carried by billions. Some of those genes are doing genuinely important things. Scientists have identified specific Neanderthal variants that affect immune response to viruses. Makes perfect sense. Neanderthals lived in Eurasia for hundreds of thousands of years. They encountered viruses modern humans never met in Africa. They evolved defenses through brutal natural selection. When we bred with them, we stole those defenses, downloaded their antivirus software, And it works. Studies show people with certain Neanderthal immune variants have measurably different responses to viruses like influenza and HIV. Not always better. Sometimes those variants cause overactive immune responses, autoimmune problems. But sometimes they help significantly, context dependent. The same is true for metabolism genes. Some Neanderthal variants help process fats and carbohydrates differently. Useful if you're eating a high-fat diet in Ice Age Europe. Maybe less useful if you're eating modern processed foods high in simple sugars. Scientists are finding Neanderthal gene variants associated with everything from skin thickness to pain perception to circadian rhythms, all little tweaks that made perfect sense in their context, but might have different, sometimes harmful effects now. And here's something genuinely mind-blowing. Some of those genes show regional variations in frequency, Neanderthal variants that are common in European populations, but rare in East Asian populations, or vice versa. That means natural selection is acting differently in different environments, even today. The same Neanderthal gene that's useful in cold climates might be harmful in tropical ones. So, it gets selected for in some populations and actively selected against in others. We're watching evolution in real time, the slow sorting of ancient genes into modern contexts. 40,000 years later, the legacy of Neanderthals is still being actively written, but there are darker implications too. Because if Neanderthal genes affect disease risk differently in different populations, that has serious implications for medicine, for drug development, for understanding health disparities. You can't treat everyone the same if they have different genetic backgrounds affecting drug metabolism. If some populations have more Neanderthal DNA affecting how they metabolize certain drugs, they might need different dosages, different treatments entirely. This is already coming up in medical research. Certain drugs work better in some populations than others. Part of that is Neanderthal genes. Ancient DNA affecting modern medicine. It's bizarre, but it's real. The past isn't past, it's literally coded into our cells, affecting us every single day. And as we learn more about the Neanderthal genome, we're finding weirder and weirder connections. Neanderthal genes that affect depression risk, addiction vulnerability, even cognitive function. Does that mean Neanderthals were predisposed to these things? Not necessarily. Remember, these genes evolved in completely different contexts, different social structures, different stresses, different everything. Taking a gene that worked fine in a Neanderthal brain and putting it in a modern human brain, that's like installing software designed for one operating system onto a completely different one. Sometimes it works fine, sometimes it causes glitches. We're still figuring out which is which, but the implications are profound. If part of human mental health is influenced by ancient genes from extinct species, that fundamentally changes how we think about psychology, about human nature, about what makes us us. We're not just products of our own species' evolution. We're products of multiple species evolution. Neanderthals, Denisovans, maybe others we haven't discovered yet, all contributing pieces to the modern human genome. We're genetic chimeras, built from parts with different origins, different histories, different adaptive backgrounds, and that's not a metaphor, it's literal. Your genome is a patchwork, some pieces from African Homo sapiens, some pieces from Neanderthals, all stitched together over thousands of generations of mixing and natural selection. You're not one thing, you're many things, a mosaic of evolutionary experiments, some successful, some still being tested, some already failing but not yet eliminated. That should profoundly change how we think about human identity, about race, about belonging, because if we're all carrying DNA from extinct species, if we're all hybrids, then what does it mean to be purely anything? Purely European, purely Asian, purely human? The answers get fuzzy incredibly fast. Biology doesn't respect our neat categories, never has. Species boundaries are suggestions, not laws. And evolution doesn't care about maintaining purity, it only cares about what works, and sometimes what works is mixing, taking genes from wherever you can find them and cobbling together something new. That's what we are, cobbled together from extinct species and surviving ones, from Africa and Eurasia, from glacial adaptations and tropical ones. We're the species that absorbed everyone else, that took what we wanted and kept moving forward, that mixed and matched until we created something that could survive anywhere. That's our real superpower. Not intelligence exactly, not tool use or language or culture in isolation. Those are just symptoms. Our real superpower is adaptability, the ability to absorb, to learn, to take good ideas from anywhere and make them our own, to mix genes from different populations and create something new. Neanderthals couldn't do that at the same level. They were more isolated, more conservative, more tied to their traditional territories and ways of life. When conditions changed dramatically, they struggled to adapt fast enough. We adapted constantly, never met a niche we couldn't eventually invade, never encountered a challenge we couldn't eventually overcome. And part of that adaptation was absorbing Neanderthal genes, taking their cold weather adaptations, their immune responses, their metabolic tricks. We didn't just outcompete them, we consumed them, made them part of us, and moved on. It's brutal, but it's also kind of beautiful, because it means they're not really gone, not completely. They live on through us in ways they could never have imagined. Here's where things get really weird and futuristic. Scientists can now create Neanderthal cells in laboratories, not cloning them, not bringing them back to life, but taking modern human cells and editing specific genes to match the Neanderthal versions. Then they watch what happens. How do those cells behave differently? How does the Neanderthal gene affect development, metabolism, function? It's like resurrecting tiny pieces of Neanderthals, one gene at a time, one cell at a time. And what they're finding is absolutely fascinating. Neanderthal versions of brain development genes cause cells to organize differently, form different patterns, connect in different ways. These aren't huge differences, not like growing a complete Neanderthal brain, but they're measurable, significant. They show that Neanderthal brains literally worked differently than ours at a fundamental cellular level. Does that mean they thought differently? Almost certainly yes, but how exactly? That's what scientists are trying desperately to figure out. Some researchers are even growing mini-brains, organoids, tiny clumps of brain cells that develop in dishes. They can edit these to have Neanderthal genes and watch how they grow compared to normal human versions. It sounds like pure science fiction, but it's happening now in labs around the world. We're slowly reconstructing what made Neanderthals unique, what made them different from us. And with each discovery, the picture gets more complex, more nuanced, less about simple comparisons of better or worse, more about different strategies, different solutions to the problem of being human. Because that's what this is really about, different ways of being human. Neanderthals weren't failed humans, they were successful humans. Just successful in different ways, adapted to different environments, optimized for different challenges. They survived for over 300,000 years. That's longer than modern humans have been around as a distinct species. They were doing something profoundly right. The fact that they went extinct doesn't diminish that achievement. Extinction is normal. 99.9% of all species that ever existed are extinct. It's the default outcome. The weird thing isn't that Neanderthals went extinct, it's that we haven't yet. Because here's the thing, we're not immune to extinction, we're not special, we're not exempt, we're subject to the exact same forces that wiped out Neanderthals. If a new disease emerged that we couldn't fight, we could collapse just like they did. If climate change disrupted our food supply catastrophically, we could starve just like they did. If we faced competition from something better adapted, we could be outcompeted just like they were. The only reason we're still here is we haven't faced that perfect storm yet. But eventually we will. Maybe in 1,000 years, maybe in 1,000,000. But eventually something will challenge humanity in ways we can't overcome. And when that happens, will we go extinct? Or will we do what we did with Neanderthals? Mix with whoever's better adapted, absorb their genes, survive by transforming into something new, because that's the other option, not extinction, not unchanged survival, but evolution into something else entirely. We're already doing it. Human-directed evolution, CRISPR gene editing, designer babies, genetic engineering. In 50 years, humans might be able to choose which genes their children have, including whether to keep or remove Neanderthal variants. Want better immune function? Keep this Neanderthal gene. Want to avoid depression risk? Remove that one. We could edit ourselves, optimize ourselves, become something better suited to whatever challenges we face. Is that still human, or is it something fundamentally new? A different species entirely? The lines are blurring just like they blurred between Neanderthals and modern humans, just like they've always blurred throughout evolution. There's no pure human, no perfect form we're supposed to maintain unchanged, just constant change, constant adaptation, constant mixing and reshuffling of genes. And maybe that's the real lesson from Neanderthals, that holding on to identity too tightly is dangerous, that refusing to change is essentially suicide, that survival requires flexibility, adaptation, willingness to become something new. Neanderthals couldn't adapt fast enough. We could, at least so far, but the future is uncertain. The world is changing faster than ever. Climate, technology, population, resources, all shifting in ways we can't fully predict or control. Will we adapt fast enough, or will we end up like Neanderthals, the dominant species that suddenly wasn't? There's another possibility though, one that's even weirder. What if we don't stay on Earth? In 100 years, humans might be living on Mars, on orbital habitats, on moons of Jupiter, spread across the solar system, adapted to different environments, different gravities, different radiation levels. Those populations will diverge genetically, physically, culturally. Over thousands of years, they'll become different enough to be considered different species. Will they all still be human, or will humanity split again? Become multiple branches like it was 40,000 years ago when Neanderthals and Denisovans and Homo sapiens all coexisted? And if they do split, will they compete? Will space humans and Earth humans come into conflict over resources? Will we repeat the whole cycle? one branch out competing the others, driving them to extinction? Or will we learn from history, avoid the mistakes we made with Neanderthals, find ways to coexist, to maintain diversity instead of collapsing into monoculture? These aren't hypothetical questions. They're challenges we might face in our lifetimes or our children's lifetimes. The story of Neanderthals isn't ancient history. It's a preview, a warning about what happens when closely related human groups come into direct competition. Sometimes one wins, sometimes both lose. Rarely does everyone survive unchanged. But here's the hope. We know this now. We understand the dynamics. We can see the patterns that led to Neanderthal extinction. Can we use that knowledge to avoid repeating it? Can we build systems that allow different human populations to coexist without one dominating the others? Can we value diversity instead of seeing it as threat? Can we celebrate difference instead of trying to erase it? These are moral questions as much as scientific ones, questions about what kind of species we want to be, what values we want to uphold, what future we want to create. Neanderthals can't answer those questions. They're gone, but their ghosts live in our DNA, reminding us of what we've done, of what we're capable of, both the mixing and the destroying. Every person walking around with Neanderthal genes is a living monument, a reminder that we're not alone in the human story, that other branches existed, that they mattered, and maybe, just maybe, that knowledge can make us better, more humble, more aware of our place in the larger web of life, because we're not the end point of evolution. We're just one more step, one more experiment, one more attempt by biology to find solutions to the problem of survival. Neanderthals were an experiment too, a successful one for a very long time, until they met us. What happens when we meet our next competitor? Not another human species, those are all gone, but artificial intelligence, bioengineered organisms, space aliens, if they exist. Will we compete, cooperate, mix? What will happen to humanity when we're not the smartest thing on the planet anymore? The Neanderthal story suggests it won't be pretty. Competition between intelligent species tends to end badly for one of them. Usually the one with fewer numbers, less adaptability, worse communication. Are we Neanderthals or modern humans in that scenario? Are we the ones who will win or the ones who will go extinct? Nobody knows. But the answer probably depends on how we act, the choices we make, the values we uphold. If we cling to human purity, if we refuse to mix or change or adapt, if we see others as competitors to be destroyed rather than partners to learn from, then yeah, we're the Neanderthals. But if we do what modern humans did best, if we adapt, mix, absorb, learn, become something new, then maybe we survive, transform, evolve into whatever comes next. The choice is ours. The future is unwritten. But the past is crystal clear, and it tells us that survival requires flexibility, that purity is death, that mixing is strength. Neanderthals are inside us, their genes, their adaptations, their evolutionary history. We're not separate from them, we're their continuation. And that's beautiful, because it means they won too. Not in the way they probably wanted, not as a distinct species maintaining its identity through time, but as part of something larger, something that survived when they couldn't, something that carried their genes to every corner of the globe. There are more Neanderthal genes alive today than at any point in Neanderthal history because there are 8 billion humans carrying fragments of their genome. That's their legacy. Not extinction, but transformation, dissolution into a larger whole, sacrifice of identity in exchange for immortality. Is that comforting? I don't know, but it's true, and it changes how we should think about them. Not as losers, not as evolutionary dead ends, but as ancestors, contributors, part of the team that created modern humanity. We wouldn't be who we are without them, literally. Our genomes would be different, our immune systems weaker, our adaptations less complete. They gave us gifts, probably without meaning to, probably without even understanding what was happening, but they gave them nonetheless. And now it's on us to honor that, to remember them, to learn from their story, to avoid the mistakes that led to their extinction, to build a future where difference doesn't mean destruction, where competition doesn't require annihilation, where multiple forms of intelligence can coexist. That's the challenge. That's what we need to figure out, because the next time humanity faces what Neanderthals faced, we might not be the ones with the advantages. We might be the ones struggling to adapt, fighting to survive, watching our world shrink. And when that happens, we'll understand what Neanderthals felt. The fear, the confusion, the desperate attempt to hold on to identity in the face of overwhelming change. Will whoever comes next show us mercy? Will they preserve our genes? Will they remember us? Or will we be forgotten, erased from history except as fossils, as curiosities, as an extinct species that once had potential but couldn't keep up? The answer depends on how we act now. The precedents we set, the values we embody, the future we create. Neanderthals couldn't choose. They didn't have the knowledge we have, didn't understand the forces working against them, couldn't see the big picture. We can, we do, we have no excuse. So what are we going to do about it? That's the question the Neanderthal story leaves us with. Not what happened to them, we know that. But what happens to us? What kind of future we create? What legacy we leave? Will we be the species that learned from the past, that found ways to coexist with difference, that survived through adaptation and mixing and flexibility? Or will we be the species that repeated old mistakes, that clung to purity and identity until it killed us, that chose destruction over transformation? The choice is ours, and the clock is ticking, because evolution doesn't stop, change doesn't pause, and somewhere out there something is coming that will challenge us, like Neanderthals were challenged. Maybe it's AI, maybe it's climate change, maybe it's something we can't even imagine yet. But it's coming, and when it arrives, we'll face the same test Neanderthals faced. Adapt or die, change or vanish, mix or perish. They chose their path, or maybe they didn't have a choice. Maybe circumstances chose for them, but we have a choice, we have knowledge, we have technology, we have awareness of what's possible, so let's choose wisely. Let's honor the Neanderthals, not with monuments or memorials, but with actions, with creating a world where their story doesn't repeat, where diversity thrives instead of dying, where being different isn't a death sentence. That's how we remember them. That's how we make their sacrifice mean something, not by preserving the past, but by building a better future, a future where no human species ever goes extinct again, where we all survive by becoming something new together, where mixing isn't weakness but strength. That's the world Neanderthals never got to see, the world they helped create but couldn't live in. Let's make sure we do better. Let's make sure their genes, living in billions of humans, get to see a future worth living. That's what they deserve. and that's what we owe them. The story of Neanderthals and us isn't over. It's still being written every day, in every human carrying their DNA. What happens next is up to us.